How does rotor diameter affect wind energy output? Imagine standing next to a wind turbine and watching its blades spin. Now, think about how big those blades are and how that size impacts the amount of wind energy it can catch. The size of the blades, or more specifically the rotor diameter, plays a big role in how much electricity a wind turbine can produce. The reason is that the energy a wind turbine captures depends on the area swept by those blades as they turn. This area is a circle, and the size of that circle is called the swept area. The bigger the rotor diameter, the larger the swept area. When you double the rotor diameter, the swept area increases by 4 times. This is because the area of a circle is calculated by multiplying pi times the radius squared. So, if the radius doubles, the area becomes 4 times larger. For example, a wind turbine with a rotor diameter of 44 meters has a swept area of about 1,520 square meters. If you increase the rotor diameter to 88 meters, the swept area jumps to around 6,080 square meters. That means it can catch roughly 4 times more wind energy under the same conditions. This increase in swept area directly boosts the amount of power the turbine can generate. Power output depends on the wind speed cubed, which means even small increases in wind speed can make a big difference. But the swept area is just as important because it determines how much wind the turbine can intercept. Larger rotors can capture more wind, leading to higher electricity production. For utilities, bigger rotors mean more energy and better efficiency. They can generate more electricity from the same wind conditions, which improves the overall capacity factor of the wind farm. But there are some trade-offs. Larger rotors need stronger, heavier components to support the blades and the increased loads. This means the turbine's tower and nacelle must be more robust, which adds to the cost and complexity of installation and maintenance. Wind farm layout also changes with larger rotors. To avoid wake effects, where wind slows down after passing through a turbine, turbines need to be spaced farther apart, usually at least 8 times the rotor diameter. This spacing helps ensure each turbine gets enough wind to operate efficiently. In simple terms, increasing rotor diameter significantly boosts the amount of wind energy a turbine can convert into electricity. It means more power, but it also requires careful planning, stronger materials, and higher costs. Balancing these factors helps utilities decide the best size for turbines to maximize energy output while keeping costs manageable.